Yeah, so welcome to the session of compiler and system testing at the ASE2020 virtual conference. And I'm Ian from Leonardo University, and I would like to, we're happy to introduce this session. The first paper will go to plug the database and play with automatic testing, improve system testing by exploiting persistent data by Diego Clerissi. This will be the presenter, so we can go to the first talk. So let's welcome Diego.
Nice
Can you share
to
the screen?
Thank you. Yeah. Let me, okay. Can you view it? If everything is okay, I can start.
Yeah, awesome.
Okay. Let's start. Okay. Thank you, everyone. I'm Diego Clerissi. I'm a postdoc at the University of Milano-Bicocca, and I'm going to present this work, which is about plugging the database and play with automatic testing, how to improve system testing by exploiting the data. So I'm not sure if, okay. Okay, one of the main challenges that you face the moment you need to, you find the moment you have to test your web application is basically the selection of input data that must be meaningful in the way that must pass all the constraints that usually can be found associated with the input fields of the forms that compose your web application. So for instance, if we consider this form, and we take in consideration the input data we provide, we can see a large number of constraints associated with the input fields, like ranges of integers that must be introduced, like date format, strings that must have a certain pattern and exist within the system, and so on. So depending on the input data you provide, you may have basically two main outcomes. The first one, which is the bad one, that is when you continue to enter invalid input data that cannot pass all the constraints together. And in this case, you are stuck in a loop, which means that you are keeping entering values until all the constraint passes. On the other hand, the moment that you reach the possibility of having good values that can pass all the constraints, you will proceed in the explorations and you will reach the next stages of applications and be able to explore larger portion of your applications. So the problem is how to select these meaningful data that can pass all the constraints. Our proposal is to exploit the existence of databases as input sources for the explorations. In particular, we can consider that applications come along with a set of databases available that were, for instance, produced by a previous step of our development cycles. Like, for instance, we may have available a demo databases, testing databases, or even a production databases if we are at that stage of the application. So we may exploit the existence of these databases that can be used for free, because basically it's just built to represent the valid state of your application. So it is likely to pass the constraints we need, and select the one we have and use it for fill the forms. Also, we do not have to configure it in any way, because basically just data that can be used easily. The problem in this case is how to solve the mapping strategy that should define which data is needed to fill with the input field. So which one we will use for the tables we have stored and available in the database. And our proposal tries to solve this mapping problem. And it's a DBInput, this plug-and-play solution that integrates with test generator tool. And basically the test generator tool, the moment they need to exercise several functionalities like entering new data into the forms, first have to query the DBInputs component that will provide the meaningful input data that is likely to pass the validity constraints. DBInput, to provide the input data to the test generator tool, will have to pass through three step process. In particular, the first one will be about a computation of similarities. The second one, identify the top ones. And the last step is about to returning the best matches. Now let's see into more details about what any of this step actually does. So let's assume we are in these situations. We have to fill the form on the left, and we have this database with several tables on the right. We need to determine the valid input data that will be able to pass these constraints that may be associated with this form. And what we do with DBInput is basically first identifying the input field that need to be filled. DBInput extracts the properties that are related to the input field, in particular identifier and name properties that are taken from the document object model describing the page, and the closest text that is usually associated with the input field, like in this case, the label on the left, username on the left. Once these properties are properly retrieved, DBInputs goes to compute the similarities across all the columns of the database we have available, and returning a value that is in a range from 0 to 1. This value indicates how the input field is related with respect to the other columns, and the higher the better. So in this case, we can see that the username input field is related with 0.94 to username column, which means there is a high correlation between these two elements. And this computation is performed by combining together two different similarity scores. The first one is a syntactical distance, which determine how they are structured, the two strings we are comparing, in particular the properties of the input fields and the name of the column. And the other one is the semantic similarity, which determine how similar in terms of the meaning are the two strings we are comparing. And this clearly is performed for all the input fields that need to be exercised. For the second step, once we have computed all the similarity score for all the input fields that in these graphs are those on the left, we obtain these three different rows, blue, red, and green dots, that represent all the similarity score between the input fields and all the databases columns. What we do next is applying a DB-scan clustering algorithm to detect the top quality cluster that will identify the best similarity score for each of these input fields. For instance, here we can see the username columns associated with the username input fields, and so on for the other two input fields. The last step of the DBInput technique is to combine together all the possible combinations of the existing similarities we computed so far with the top clustering algorithm. So we put together all the possible combinations. We get this list of similarities that cover all the input fields. What we do next is to determine which one is the best one. So we will compute two measures, a Q value that indicates the quality of the similarity, which is the mean of all the similarity scores computed so far, the higher the better. And the other one is the number of tables involved into this combination. In this assumption, we consider that having lower number of tables indicates that the data should be more coherent among each other. For instance, they should describe the same entity by involving a less number of tables, like having the data of a user spread just into one or two tables, instead of having a spread number of columns across a higher number of tables. So by considering these two measures, the one that must be kept high and the other that must be kept low, we select the best similarity combination, that in this example is the first one, that will provide meaningful input data for exercising the form. So it will point basically to the columns that in this case are about just of a single table. These three columns will help to extract the records that will be used for exercising the forms. And since these data come from the database, it is reasonable to think that should pass the constraints of the application. So we evaluated our proposal by integrating three different input generator technique into an ABT tool, which is auto black test tool that performs web testing web applications. In particular, the approaches are a random generation of alphanumeric strings, link tool, which basically query DBpedia to return meaningful data, and the aforementioned DBInput, that is the one we propose. We selected 4 different web applications, the one on the right, coming from different domains, from an ERP, insurance, tickets, and industrial applications. And we performed several reasons about their size in terms of number of tables, number of constrained forms to determine how they were so different among each other. We formulated 2 research questions for our evaluation. The first one is about the effectiveness of DBInputs when different configurations are defined for the technique. So to determine which one could be the best one when DBInput is applied. And the second research question is about a comparison of the approaches for the input generators techniques. So which one is the best and if DBInputs can outperform the others. We also formulated 2 metrics to answer the research question. The first one is the at least once matrix that computes the number of forms visited by each technique with either valid or invalid input data. And the other one, I'm not sure if you can, okay, is the at least half matrix that determine the consistency of the explorations, which basically is the number of forms that are reached with both valid and invalid input in at least half of our executions. So to perform our evaluation, the setup of the experiment is the following. Since we wanted first to address the research question 1 about the different possible configurations for DBInput, we defined 3 possible configurations, starting from the application databases that we have on the left. We basically split these in 2 halves. The first one used always by the running application, and the other half selected depending on the kind of configuration we wanted. For instance, for the DBInputs techniques that uses just a disjoint database, we selected a database that share no records at all with respect to the one running on the application. For the DBInput equals, basically we use the same half of the database. And for the last technique, the DBInputs overlapping, we combined again the first half, that is the one used by the application, with the second half. We also introduced a logger to instrument the test generator tool and have automatically computed the number of forms visited during the explorations and the consistency in such explorations. And finally, we set up 10 runs for each application and approach. What we obtained so far, the results about pertaining research question 1 is shown in this graph. We can see here the bars represent the first metric, which is the number of forms visited with either valid on the left and invalid input data on the right. We can see that the first configuration, which is DBInput disjunct, which means when the database used by DBInput is totally unrelated to the one used by the application exercised, outperformed the other 2 approaches, in particular when valid input data were used. It reached more than 40 forms with respect to the other 2 approaches, and also was able to reach more forms even with invalid input. We can see on top of these bars a light blue colors that indicates also the number of forms that were reached with just by 2 or by a unique of these configurations, and DBInputs was able to reach more forms than the other 2 approaches, than the other 2 configurations. And this is reasonable to consider that since it was better to explore, maybe it was also able to explore different forms than the other 2 approaches. So these results depends on the forms that were visited. And we can also see the matrix 2, which is about the computation of forms visited in a consistent way, which is the black lines within all of the bars. Again, DBInput disjunct was able to reach 16 forms compared to the other 2 techniques. So it resulted also better in terms of consistency. If we compare instead the DBInputs with the best configuration with respect to the other 2 input generator tool, we can see again that it outperformed the other 2 techniques, random and link, in particular when valid input data are used. And this is explained by the fact that it uses databases values with respect to the other 2 techniques. And in particular, we can see that it was able to reach almost 45 forms with respect to the other 2 techniques. And it was also surprisingly good even by exercising the form with invalid input. Again, it resulted better also in terms of forms executed uniquely by the light blue colors on top of the bars. And also with respect to the matrix 2, it was able to exercise in a consistent way more forms than the other techniques, 18 with respect to 7 and 6. To conclude our observation, here we can see just groups of the functionality divided by categories, in particular taken from all the applications we considered. We have add, edit, search, and other functionalities on the right, and on the left summarizations. We can see that, again, DBInputs was able to reach at least a median value of valid outcome, which means valid succeeding of the forms of 0.5, while the other two competing approaches had just some outliers that reached or go through this value. And in particular, DBInput was able to exercise much better add-ended functionalities. And so to conclude, we identified this problem of selecting valid input data that can clearly determine the performance of the explorations of your web applications, which may reach or not reach specific states depending on the values you enter. We propose this technique that in 3 steps tries to solve the problem of selecting meaningful input data from existing databases and provide this similarity with respect to the input field that must be filled. And we evaluated our technique against other approaches and considering different applications, resulting that DBInput was better both in terms of explorations of of forms with input values, but also in terms of consistency in such explorations. You can see on the bottom of this slide this URL that brings you to the tool that is available and also with the materials we used for our evaluation. Thank you.
Yeah, awesome. So very good timing. So we have a few minutes for the questions. Anyone, if you have a question, you can raise your hand and maybe I can unmute you to raise any question. And I will also watch the Hova app to see if there is any question from the internet. So any question? So just a quick question. So I think it's a very nice technique to test the forms. So any idea if we can generalize this technique to test some continuous interactions with the website with forms and AJAX, like structured data with JSONs, like interaction with the servers? Can we generalize this approach to the testing with such structured data?
Well, I guess we could. Basically, the approach just need to have a database available for the exploration. So it provides just the input. So the tool that will explore the applications is just separated for our proposal. So basically, I assume it does. It could be. It depends clearly if the application has a sort of database available, but even if it does not have one database, could, for instance, rely on domain-related databases to use. I think it should work as well, because it depends clearly on